Standard 6.8, solve logarithmic equations. Alright, so whenever we're solving a log equation, we want to do two things. We want to condense, and then we want to somehow get rid of our logs. So let's take a look at our first example. Here we don't have anything to condense. We have one log on the left side and one log on the right side. So let's write here, first we want to condense if possible, and then we want to get rid of our logs. So how do we get rid of our logs here? Well, when you have a log on both sides, you can basically drop the logs. So in this case, since we have a log on both sides, we can drop the logs and get x squared minus 6 equals x. And then it's a matter of solving the equation, whatever type of equation it may be. In this particular case, this is a quadratic equation because of the x squared. So we want to set it equal to 0. Put minus x minus 6 equal to 0, and we solve quadratics by factoring. So we want to find two numbers that multiply to negative 6 and add to negative 1. That would be negative 3 and positive 2. And if we set each of these factors equal to 0, we get x equals 3 and x equals negative 2 as our solutions for x. Now what we want to do is make sure our values for x don't produce negative logs, because there's no such thing as a log of a negative number. Notice if we take negative 2 and plug it in for x here, we are taking the log of a negative number. And so we can't have x equals negative 2 as one of our solutions. X equals 3, however, works because when you plug 3 in for x in either logarithm, you're going to be taking the log of a positive number. So in this case, our answer is x equals 3. Again, our strategy was to condense if possible, which in this case it wasn't, and then to drop the logs because you had one on each side. All right, let's take a look at this next example. So again, let's condense if possible. Well, here we have the subtraction of two logs. So when you're subtracting two logs, you can condense by division. That's our quotient rule. Look at the standard 6.7 video if you need more help with that. So the quotient rule says, hey, we can condense by dividing our argument. So we're going to divide the x and the x plus 2. Alright, so we condensed, and the next step is to get rid of our log. Well, we have a problem here because we have a log on the left side, but we don't have a log on the right side. So we can't just drop the log. In this particular problem, the way that we're going to get rid of the log is to convert to an exponential equation. So our base here is 3, and our power here is negative 2. We're going to make this 3 to the negative 2 power equals x over x plus 2. So again, you want to convert when you can't drop your logs. Alright, so now we're going to solve this as a regular equation. 3 to the negative 2 is 1/9. And because we have a fraction equal to a fraction or a proportion, we can cross multiply. So let's do 9 times x and 1 times x plus 2. And so we get 9x equals x plus 2, or 8x equals 2, or x equals 2/8, or x equals 1/4. And again, if we take 1/4 and substitute it for either x, you're not going to be taking the log of a negative number, so x equals 1/4 is a valid solution. Again, let's review the process here. In either case, you're going to condense if possible, which was not possible in the first example, but was possible in the second one because you were subtracting two logs. If you were adding two logs, you could condense with multiplication. In this case, because we're subtracting, we condense with division. And then you're going to get rid of your logs, either in one of two ways. If there's a log on both sides, like the first example, you can drop the log. When you drop the log, you end up with a regular equation that you can solve. And in our second example, we couldn't drop the log because you only had it on one side. So in this case, you're going to convert to an exponential equation. That's how you're going to get rid of your log. And then again, solve like you would a regular equation. This is standard 6.8, solving log equations.